Hello guys, welcome to Code, and today we are looking at a Spring Java engineer roadmap. We want to give a quick roadmap into how you can essentially go about starting your Spring Boot development journey and sort of suggest the ways and the steps that a developer can navigate their first few steps, first few um, projects, and what to look out for, what to consider, what to take into account. So essentially, we are trying to give you a guide into the things to look out for in this journey as a developer and as you grow as a dev. So this is just a high level sort of a roadmap. Uh, we will continue to be sharing more detailed roadmaps as we go so that you are able to be in a position where um, you get to see what goes deeper into all of these and break it down even further to see all the tutorials that we offer in the channel, and you can basically understand where they sort of fit within the Spring Boot stack and within the developer engineer roadmap guide. So without wasting any of your time, let's just go through with this. So first things first, we essentially want to start at the core, which is the Java fundamentals. So in the core, you basically want to understand the fundamental concepts that have to do with the Java development language itself. So object-oriented principles, solid principles, your data types, declaring variables, what the different types, what is the syntax that has to do with Java, um, tools like your IDEs. We would recommend you use your IntelliJ. So with IntelliJ, it is sort of the best IDE in my opinion, and it's feature rich in terms of the Java development stack. So I would recommend IntelliJ. So in the channel, you might see me using Spring Tool Suite, and that is because I'm using this PC which has Spring Tool Suite, and I'm comfortable with Spring Tool Suite. But on my day-to-day, I do use IntelliJ for my development projects. I have no problem with either one of the IDEs. So if I were to recommend one, I would recommend your IntelliJ. So in the core concepts, you are looking at obviously your object classes, abstraction, inheritance, polymorphism, and things like that. So you want to dive deep into all of those solid principles, single responsibility, open close principles, list of substitution, um, dependency injection. So all of those principles you would want to take into account. So essentially, these are the core concepts of Java object-oriented programming. And once you've grasped those, you sort of want to move into a phase where now you are developing using a framework. So a framework that is feature rich, that has much more to offer than just you having to do all the hard work for your um, project, for your applications, for your infrastructure. So then we have the basics, the Spring framework, um, which gives us Spring concepts such as your application server being readily available, embedded Tomcat. That is one of the features that we have in Spring Boot. So you don't have to configure an application server. You can just use the default application server, and you do have some application. You can use the application properties to configure the server, the ports, and things like that within your application properties, and those will be readily available on application startup. So a lot of dependencies are available with feature rich, such as your actuator, your health checks, your matrix, and your status of your application, microservices, and things like that. So Spring Framework is sort of rich in offering all of these features readily available, and you can basically just use those instead of having to um, build your entire application, and on top of that still build um, the infrastructure to run your application and maintain the environment and all of those. So Spring Framework offers those capabilities. And then now we move to Spring Boot. So Spring Boot is essentially um, the the backbone of the Spring Framework, because it allows us to have tools such as your Spring Initializer to scaffold a new Spring project or a Spring application, and have a project set up with dependencies that we need. And if you are a follower or subscriber in this channel, you see that every Spring tutorial, we start in the Spring Initializer, we configure the project, we configure our package, our metadata, how we want to package our deployment artifact, and what dependencies we need, your Lombok, your Spring Web, your Spring Security, your Spring Data JPA. All of those dependencies will be managed depending on which dependency management we choose. We can have Maven, we can have Gradle, but in most cases we use Maven. So we define all of those dependencies that we need, and they will be clearly specified in our pom.xml file, and we just package that in our initializer, and we export that into a zip file. Then we open it in our IDE, and that gives us our scaffolded project. It already has your Tomcat application, as I mentioned, application server, and it has your database or your data source dependency embedded in there when you define it in the initializer, and you only need to just configure the connection or implement the connection to your specific database, SQL Server, Postgres, whichever database that you prefer or that you are using, and that basically allows you to interact with your databases. So that's basically Spring Framework and Spring Boot. Those are the capabilities that you would get by using those. So we're moving on to APIs. So RESTful APIs, and in with Spring Boot, when you create your application or when you build your application with the Spring Initializer, you essentially have a Spring Web dependency which allows you to create REST APIs. So when you build REST APIs, you need to understand the REST principles that you need to implement for your APIs to not only just be exposed over the internet, but also your APIs need to be able to interact with other services or interact with other systems and users. The payload, the request, the response types. Is it a JSON response? Is it an XML response? All those capabilities you need to cater for. You need to look into how do you maintain those APIs that you have within your application. Can you maintain, as I mentioned earlier, things like your actuator, the health status of your APIs, what's going on there? Are they up? Are they down? Are they failing? What's going on? So all of those checks is offered by Spring Boot. So those capabilities are very, very helpful when it comes to debugging your APIs and knowing what goes into your APIs and what is expected output from your APIs. So that's basically that with APIs. And then the next thing that you'd want to get or dive deep into is data with Spring Data JPA. So Spring Data JPA essentially looks at your databases, transacting with your database. So Spring Boot uses Hibernate as the object relation mapper. Is it object relation map? I think it is. Yeah, I think it is. Object relational map. Yes, because then it actually transacts directly with the database. So that is essentially what handles all of your database transactions. And with Spring Data JPA, you'd want to make sure that those the definition and the connection to your database must be secured or protected, so that those are not lying around in your application. And JPA can essentially handle your SQL queries if you're connecting to your SQL database, in this case Postgres or similar databases or relational databases. So this feature allows you to transact with your database easier. It scaffolds a lot of your queries. Once you specify your database entities, you map your repositories, and you can start implementing your business logic in your services, then transact accordingly in that sense. So that's basically that with data. The next thing now is security. So with security, um, you essentially want to make sure that your application is secured. So things like your authentication, your authorization, your role-based access control, those need to get right. You need to get those right, implement those accordingly. You can decide which authentication mechanism you want to follow. There's basic auth, there's API authorization, there is JWT, token-based authentication, and a lot of more. There's OAuth authentication. So all of these authentication mechanisms that can be implemented to make sure that all the users that access your system are the authenticated or allowed users, and they are basically authorized to access certain endpoints, or they are restricted at some level. So that is basically what we have. And the next point would be an MVC. So Spring does offer an MVC architecture, which is a model view controller. So you do have models that pass data into your view via the controller. So the controller is the middleman, or the middle layer that sort of sits between your view and your models, because there's a business logic that says I'm going to this view and I want to have this type of data. So your controller handles that, which data needs to be fed to which view, and the view is the user interface, and that interface will then display that particular view. Let's say in case of an employee, you'd have employee details view, and the model will be employee details model, and it will be fed into that particular employee detail view via the controller. And it's basically that entire architecture that ties everything together into one. So also security is very emphasized in these architectures, to make sure that the right users get to see the right data, and they are allowed to see the data that they are exposed to. So that is basically that. And the last but not least, we have the microservices architecture. So the microservices architecture would say it's sort of much more rich and much more complex, in a way that you want to have your system sort of robust, and it or your systems rather are robust and have that segregation of responsibility, in a sense of, if I have a restaurant, for example, I want to have a order service that is separate from the uh, restaurant service. So if someone orders on the one service, the ordering service, that service can alert the restaurant service that someone has ordered something. Then the restaurant service will prepare that order for that person. Once that order has been processed, then it can be sent back to that particular client that ordered that particular meal, and that particular journey can be completed. And in between there can be a layer of, let's say, your RabbitMQ or your Kafka, or whatever messaging mechanism that you would decide to have those two services communicating, but they are not dependent on each other. They just share information about a particular transaction. In this case, it can be an order from a client. It goes into the restaurant service. The restaurant prepares it and updates the order service and says, "Oh, we received your order. We're preparing it." So, and once they are done, they say, "Okay, now we are done with your order. We are taking it to you. You should expect it in the next few minutes." And then once the order has been received, and it can basically be a case of order received, and you complete that transaction in that sense. So a microservices architecture speaks to that, to say this is a transaction, and this transaction has multiple layers in between, and it can say if someone is trying to order something, and maybe let's say the payment service whilst they're ordering fails, then that order won't go through to the restaurant service. So now you see that even though the order has failed on the order service, it doesn't impact the restaurant service, because the restaurant service is not aware of what is going on until every step is checked from the order service independently. And then once everything is successful, only then is it shared via that messaging channel. Can be your queue, can be your Kafka, and only then is it sent to the restaurant service, and they pick it up as a authentic and valid order, and they can act on it, and then process that transaction accordingly. So this is basically what microservices architecture aims to achieve, to have that separation of responsibility, and we can have different teams working on these different microservices without impacting one another, and there would be that awareness of dependency, just in terms of deployments and things like that, which can be managed internally without impacting the service availability on either end. So this is the robustness that you have with the capabilities of service discovery, load balancing, API gateway. So all of these are available to make sure that you guarantee high performance, highly scalable, and highly performing services and applications as well. So in microservices architecture, you want systems that speak to other systems, and they should not be tightly coupled, so that it allows for that flexibility within the journey or the user journey of a particular business process. So that is what you aim to achieve. And as you can see that this roadmap continues, there is a whole lot more to be shared, a whole lot more to be discussed. But for now, just wanted to keep it short and sweet, and we can sort of manage this chunk. And as we go along and share more roadmaps that are much more detailed, you would see that there's a lot that we still have to look into, such as your caching, your profiling, your actuator. We only highlighted the actuator, what it can do, its capabilities, the matrix with your services and applications. So those we just highlighting so that you are aware that there's a whole lot more to be discussed within the Spring Java Engineer roadmap. So for now, I would say please do like and subscribe. If you do have a comment, please share it down below. And please do watch out for the next roadmap, which will be much more detailed, and we keep on revisiting these and making sure we give it much more detail as we proceed. But for now, cheers.